So the first type of polymer we're going to look at is a basic addition polymer. You have hopefully looked at what an addition reaction is. An addition polymer is where the addition reaction happens over and over and over again to form a long polymer chain. And the way it works is, this is the most common one. This particular monomer is called ethene, or the common name for it is ethylene. Okay, and you see here, to get this particular reaction started so that the monomer units can start linking together, you have to do what's called initiate the reaction, start the polymer chain reaction, and that is done using a free radical catalyst. And catalyst is used a little loosely here. It's really a free radical initiator would be a better word, because in the truest sense of the term, catalyst would mean that catalyst means speed up the reaction, but catalysts are not consumed across the course of the reaction. But in this case, you'll see the catalyst does become a part of the product. So that term is used sort of loosely here. So anyway, free radical, meaning that it's got an unpaired electron. Anytime you have an unpaired electron on a molecule, that molecule, it becomes very, very reactive, because an unpaired electron is unstable. So what happens is you'll have a whole bunch of monomer in a pot and add a little bit of the initiator, and it will collide with a monomer unit. And what happens is, when it does, is this double bond here is broken, and one of the electrons in the double bond moves over here and forms a new bond. Remember, a pair of electrons is a bond, and each one of these dots is representing an electron, and forms a new bond right here between the initiator and this carbon. So that's the initiator and this carbon. Well, that leaves just one electron and then a pair of electrons here. This one electron will be available to, because remember, this is a two-dimensional image model of a three-dimensional thing. So this one electron is just residing on this carbon atom, and it is now available to form a new bond. And so for now, it's just very, very reactive. And what happens is, this very, very reactive free radical here will combine with one of the electrons from this double bond right here will come over. This will come over and form a new bond. So the new bond that's formed between this free radical and this double bond is this bond right here. And that leaves another electron available. That's this one right here. That's available now to continue on this chain reaction. So this is going to collide with another monomer unit, et cetera, et cetera, et cetera. So that's how you grow a polymer chain using addition polymerization. So remember, with addition, you have two reactants, one product. Two reactants, one product. And it just keeps going on and on and on. All right, and the way these types of reactions are written is like this. The number of monomer units is abbreviated with an N, because with these polymer reactions, you can get varying, what we call chain length, depending on the conditions under which you run the reaction. And so in this case, the balanced chemical reaction for an addition reaction is, you're going to have two initiators. One is going to start the thing, and the other is going to stop the thing. And you're going to have N number of monomer units, and they're going to form a chain that's going to be N monomer units long. So this is the shorthand way, or this is the way in which polymer reactions are symbolized, because if you draw out the whole polymer, you could have hundreds and hundreds of units. It's just not practical. So this is the way that we represent polymerization reactions. All right, so there's typically a very, very small amount of the initiator, a large amount of the monomer, and you can end up with chains with hundreds and hundreds of monomer units linked together. Okay, so let's look at an example here, see if you're getting this. In this particular exercise, it says, suppose that N equals 4. So in this previous reaction that we just took a look at, suppose that the N here is 4. And rewrite that equation to indicate that. So we'd have 2 R's plus 4. Instead of N, we're going to have 4 monomer units, okay, which is ethylene, to give the product is going to be polyethylene. It's going to be a polymer that's 4 monomer units long, So you put it in brackets, the monomer unit in brackets, and then you say 4 down here, indicating that there's 4 of these, and then there's an R on either end. Okay? So that's how we would represent a polymer that's 4 units long. And then B, it says draw the structural formula without brackets, so draw it out. And so that's going to be 4 of these is going to give me a total of 8 carbons. So 1, 2, 3, 4, 5, 6, 7, 8, and then of course the R is on the end. I'm not going to draw in all the hydrogens because it's too messy with this big Sharpie, but you would have hydrogens on, you know, saturated across all those carbons, okay, like this, only I'm not drawing them all in. All right, and then the last question is, in terms of its molecular structure, how does the product differ from octane? Well, octane, you know, is a basic alkane with a chemical formula of C8H18, and this particular structure that we have here, this polymer, has the formula C8H16R2. And so instead of having 2 hydrogens on the end, those hydrogens are substituted out in this case for R, and R is some small molecule, and there's various types, but sometimes there's small hydrocarbons with a free radical nitrogen or oxygen on them. So, you know, I don't know what exactly R is. There's lots of different initiators depending on what you're doing. But the bottom line is it's different than octane because it has the R's instead of just H's.